class, we look into domain and range of square root functions. And here we have some questions to solve, which is find the domain and range of the following functions. Let's solve. Alright, so we have question 1, f of x is equal to root x. Now for square root functions, for a real valid function, for real value functions like this, square root, we can't take the root of a negative number. We don't do that. We can't take the square root of a negative number. We don't do that. That means we are going to make our input have to stay such that it won't be negative. Yeah. So my domain df is that s should stay, the input should be such that our s should be such that our x is greater or equal to 0. Yeah, x is a member of real number. Yeah. So that's it. That's it. Numbers bigger or equal to 0 are the non-negative numbers we have. Numbers bigger than 0 are numbers that will work in this function. So once s becomes any number within this value, then you have an answer. Yeah. So this thing also can be written like this on interval notation. That will be from 0 down to infinity, always open. Here we close to show that 0 is included. That's our domain. You can also write this thing in another way. Yes, you can say domain is all real numbers except the parts that will make it undefined. And what's that part? The part that will not work. Everything will work except the part that will not work, which is where s is such that s is less than 0. Yeah, s is also a real number. Yeah. So this part will make it undefined. Numbers less than 0 are negative numbers. They will not work. So everything will work except this part. Yeah, so this way the domain can go like this one or this one. Now the range r sub f is equal to, for square root functions, the output can never be negative. The output is always positive. That's why our range here is going to be from 0 down to infinity. Yes, that's the possible output. When x is 0, we have root 0, and that's 0. The output can be 0. Then, if you keep on going, if you put high numbers, the output becomes also high down to infinity. We have solved question 1. I hope it's well explained. Yes. Now let's solve question 2. Question 2 says root of 9 minus x. It's just simple. f of x is equal to root 9 minus x. So domain here, d sub f is equal to s such that the contents of your square root, everything inside the square root should be such that it is greater or equal to 0. X is a member of the real number. Yes. That's it. Now, this inequality here is not well simplified, so we can go ahead and simplify it. So can make it look better. 9 minus x being bigger than 0, when I solve this, I'll have 9 minus x, so 9 is bigger than minus x going over, I'll have positive x. When minus x goes over, the sign, this inequality sign will not change. When minus x go over, this inequality will not change. Take note. It will only change when you divide or multiply by a negative number. When you divide or multiply by a negative number, that's when the symbol will be reversed. Yes. Yes. Or this, watch this now. If I am taller than you, that means you are shorter than me. If I am bigger than you are smaller than me. That's it. So if 9 is bigger than x, automatically we can say that s is less than 9. That's when the inequality will change. Also, let me also show you again, when you have a fraction like this, a over b is less than c over d. When you spin the fraction, like when you reverse the fraction to become b over a and d over c, you have to reverse this symbol here to this way. That's when you change inequality symbol, when you spin a fraction. Alright, back to business. So I am saying that if I simplify this, I will have this. So I can go ahead and change this to this. And that will be that the domain is S such that S is less than 9, where S is a member of the real numbers. Yeah. Also, I can write this thing on my interval notation to be. I am just giving you everything so that you know any notation you see, maybe it's OBJ, you know how to choose your answers. So this could be written as minus infinity down to 9 is strictly less than 9. Strictly less than 9, that means I have to open 9. That's it. Yeah. Also, I can say my domain is all real numbers apart from the part that is undefined, the part that will not work. This part is the part that will work. From law of trichotomy, the negation of this gives us s bigger or equal to 9. So I can say here, I can remove where s is such that s is bigger or equal to 9. This part will not work. This part is the part that will make the function undefined. If you check well, if I say pick a number, oh, my mistake. Sorry. If I simplify this, I have to come down with the symbol also. This goes like this. In that case, I have to include 9 by closing 9. Yes, it's actually a mistake. It's not planned, it's just a mistake. No one is above mistake. So that's it. So in that case, if I have to negate this, based on law of trichotomy, if I negate this, I don't have to include this one here anymore. So if I pick a number that is bigger than 9, then it will not work. This portion will not work. Now that's why we'll say all real numbers except the parts that will not work. Domain is where the function can work, which is this. Where the function can work, which is this. Now, you can still say that domain, is where the function can work. Yes. So we can still say the function can work everywhere except at some point, which is this point. If you check numbers bigger than 9, for instance, 10. When you plug 10 here, 9 minus 10, you have root minus 1. The function will not work. So all these parts will not work. So all the numbers minus the parts that will not work is also your domain. Yeah. Now your range. The range must, all square roots, your range must start from 0, provided it's not a fraction, just square roots. All of them must start from 0. Yes, 0. Sometimes it will reach infinity, sometimes it will stop on the way. But this one is going to approach infinity because in our domain, we are fixing numbers less than 9. And when we put, for instance, minus 91, it becomes 9 minus 91, which is now root 100, making it big. If I keep on going big in the negative direction, I'm having more and more positive answers. In that case, my range will approach infinity. Range is just the minimum possible output down to the maximum possible output. Yes. Alright, that's it. Let's take one more on the example on the board. We have g of x equal to root 16 minus x squared. Very simple. Here, g of x equal to root 16 minus x squared. Now, dom g, we know dom g is that s should be such that the content of the square root, which is 16 minus x squared, should be greater or equal to 0. S is a member of real numbers. Yeah. So now, we have to go ahead and simplify this. If you know math very well, you can simplify it. This will be 16 minus x squared is bigger or equal to 0. Since 4 squared minus s squared bigger or equal to 0, difference of two squares, you can say the difference of two squares is just to do 4x bigger or equal to 0. Difference of two squares, that means one takes plus, one takes minus. That's it. So with this, we'll do our truth table. When we solve this, you will see that your solution, if you can solve inequality, for those who can solve it, check our videos on inequality. We'll use this as an example. Yes, so when we solve this, we're going to have it that the solution set, let me just show you at once. Now, the zeros here, what makes these things 0, if you check well, is when x is here minus 4. Here, when x is what? 4. That's what makes them equal to 0. Now with this, you find a number line. Your number line looks like this. Yeah, 0 can be in the middle. 0 should be in the middle. The minus 4 is on the left and 4 is on the right. Yeah. So our quadratic is negative. We have an n-shaped parabola. Let's just draw it to be n-shaped. Okay. So what happens? This region is the region bigger than 4. This region is the region where you can say that minus 4 is less than x is less than 4. Like where x is in between -4 and 4. Yeah. And here is where x is -4. This is where x is less than -4. So that's what happens. Let's pick a number from any of them and check out the solution set. Now let's pick a number bigger than 4. So what happens? For instance, 5. 5. Let's see. Let's take 5. Number bigger than 4. Let's take 5. So 4 plus 5, 9. 4 minus 5, minus 1. 4 times here becomes 9 times minus 1. That is minus 9, negative. So negative here will give us negative. Yes. Let's take a number from here. Take a number in between -4 and 4. For instance, let's take 2. Let's see what happens. 4 plus 2, 6. 4 minus 2, 2. 6 times 2, 12. Positive. So this region gives us positive. This region. Yeah. How about this region? Automatically here becomes negative. One says minus, here is plus, here becomes negative. Let me still show you. If I have to choose a negative number, I can choose -5. -4 plus -5 is -1. 4 minus -5 is 9. -1 times 9 is -9. So here becomes negative. This region. Yeah. Now, the region we are going to choose is the region bigger than 0. So whenever you are bigger than 0, you are positive. So we are choosing this region here as our solution set, which is this thing as definition. Remember, we have here bigger or equal to, you include it. So my solution set to this is that my domain dom G is S such that -4 is less than or equal to x as s is less than or equal to 4. And I was too fast in solving this because I assume you have idea of inequality. Domain for square root is simple. It's just to say everything inside my square root is bigger or equal to 0. If you have strength, you simplify it with inequality to this point. If you don't have strength, you can leave it here. So I can now say that my domain for that is on interval notation becomes -4 down to 4. Here it's closed because it's inclusive. Also here it's also closed. That's it. Or I can still take from the negation. That will be all real numbers except s such that s is less than 4 union s such that s is bigger than 4. Yeah. That is also my domain, but this last one seems confusing. Take the one you understand. Yeah. So my range for this function r sub f will be, I told you, all the square roots will start from 0. So I'll have it from 0 down to, alright. In this function, yeah, nice example. So this one now, if you look very well, the minimum function here is when x is 0. When x is 0, we have 16 minus 0 squared, which is what? 16. Now the root of 16 is 4. Yes. Now we can't go above 4. Ask me why. Because when we put a number from our domain, which is -4 to 4, The highest number we can put into the function is 4, and lowest is -4. These two endpoints, when we put them inside, we'll have 4 squared, that is 16 minus 16, that's 0, with 0, 0. So we will start from 0, yes. So as we are going, we can never go above 4, because the highest output is when x is 0, and that is root 16, which is 4. This is not clear, I think. Maybe we'll take more examples in the app to give you a clear vision of what we are saying. Thank you for this wonderful class. Once more, I am Holgate Emmanuel. Thank you.